everybody, it is Sam again from the GSLAC STEM team. STEM, of course, standing for Science, Technology, Engineering, and Math. We've got another STEM activity video for you guys today. This time we are following along with the weekly Scout Challenges theme of math, so we're going to be doing a math activity. We're actually going to be talking about one of the coolest numbers out there, and that is pi, spelled P-I, not P-I-E. Pi is what's called a constant, which means it does not change. It is the same everywhere. And it is actually a ratio or a comparison between two measurements of a circle. We're going to talk more about that in a second, but first let's talk about what materials you're going to need for this activity. You're going to want some scissors. You're going to want a pretty good length of string. And then you're just going to want to find some differently sized circular objects around your house. I've got a placemat, a coaster, and a clock that I have found. You do not have to use these exact same items, just any kind of flat circular objects should do. All right, let's see how we're going to do this activity. All right, so hopefully you have your circles at this point. What we're going to do now is actually see that relationship between those two measurements and that constant pi, 3.1415. So we're going to look at two measurements on our circles, and that is the circumference, which is the outside all the way around the circle, and we're going to see how that compares to the diameter, which is the measurement across our circle. Basically going to see how many times the diameter can fit into the length of the circumference. So you're going to take your string and you are going to, around one of your circles, wrap it all the way around that outside edge, that circumference. Once it meets your piece of string, that's where you're going to cut. So mine met there. You can see that now goes all the way around my circumference of my circle. So now let's take this string, which is the length of the circumference, and basically see how many diameters we can fit in there. So let's go ahead and measure our first diameter. Looks like we're going to at least get one. Yep, so one diameter. And, oh, yep, 2. And let's see. Looks like 2 and 3. 3 and just a little bit left over. So we had 3 diameters and just a little bit left over compared to the circumference of this circle. Let's try out our clock and see what we get for a relationship there. So we're going to take our clock again, just like we did with the other one. We're going to take a piece of string, go all the way around the circumference, and cut. Again, now this piece of string is the length of the circumference. Let's compare that to the diameter, see how many diameters we can fit in there. Okay, at least one. So 1. Okay, 2, and cut. 1, 2, and 3, and once again it's 3 with just a little bit left over. 3 diameters and just a little bit extra. What I want you guys to do is find some other circles in your house, test them out, and see if you measure the circumference, then take that same circumference string and cut how many pieces you make, and if there's 3 and a little bit left over. We would guess Since pi is a constant, you should see that every single time. There should always be 3 and a little bit left over, that 0.1415926, continue on, left over for each diameter fitting into the circumference. All right, well, I hope you learned a little bit. I hope you do this at home with your own circles. If you like what we are doing with our STEM activity videos, feel free to check out our virtual STEM fair we have going on this summer. It is on our Facebook page, so check out those details. I hope you learned a little bit, hope you had some fun, and most of all, I hope you keep scouting. Thanks, bye.